So, first of all, I wanted to say a few things about what the word sound actually means. Sound, sometimes also called audio, is basically anything that we can hear with our ears, or that can be played back through loudspeakers. So sound is actually changes in air pressure, which sounds a little bit sciencey, and I apologize in advance because I am a scientist and an engineer, but I'm also an artist and a creator. But I find it really useful to understand a little bit about how sound moves around in space. So this video here shows what a sound wave looks like. It's captured with a special camera that shows the changes in air pressure around the hands when somebody claps their hands together. So what we hear as a clap is actually a pressure wave that's created by the hands coming together at high speed, and that pressure wave gets sent out through the air in all directions in a spherical shape, and when it meets our ears, our eardrums are very sensitive to changes in pressure. So when you hear a pressure wave meeting your ear, it sounds like a loud sound. It's very similar to how a wave moves across the surface of water. So if you have a pebble that you drop into a pool of water, you see the ripples get sent out across the surface in a circular shape. The very similar thing happens in air with sound. So you clap your hands, the ripples get sent out across the air rather than the water. So it's good to understand that air is a fluid. If you travel along quickly on a bicycle, the wind that you feel blowing in your face is actually because the air is quite thick. It's a fluid medium. Even though we can't see it, it's there. And sound is able to travel through air. In the vacuum of space, there is no sound because there is no medium for the pressure wave to travel through. On Earth, we've got air, and we are able to hear because the air transmits the sound. To capture sound, we use microphones, which behave very similarly to human ears in that they change fluctuations in air pressure into tiny amounts of electricity. In the case of a microphone, we can record those tiny changes in electrical current into digital audio that we can then manipulate in an audio workstation and then play back through loudspeakers or headphones. In the case of our ears, the tiny amounts of electricity our ears generate get sent along nerves to parts of our brain that process the electrical signals into what we think of as sound. It's important to understand that our brains are processing the signals in ways that help us understand the world around us. And we will be exploiting that processing, which is known as psychoacoustics, to produce audio experiences that our brains think are real. It's the same principle as virtual reality for the visual senses, but applied to the human hearing system. So that sums up a tiny bit about what sound or audio is. The next question is, what is spatial audio? Spatial audio describes a variety of techniques for simulating the 360-degree sound field that occurs in a real three-dimensional environment. In the real world, sound comes from every direction, all the time. You can't close your ears. You are always hearing and listening every minute of your life, even when you're asleep. The three dimensions of reality are width, where sounds can come from your left or your right side. Then the second dimension is depth, where sounds can appear to be in front or behind you. And the third dimension is height, where sound sources can be above or below your ear height. The most basic form of recorded audio is what we call mono. Mono is a single channel of audio that could be recorded with a single microphone and can be played back over one single loudspeaker. It has no dimensions at all. The sound contains no spatial information about the subject of the recording. The next type of audio you might encounter is stereo. This is a two-channel recorded audio format that allows the panning of a sound from left to right across the stereo field, giving the recording one spatial dimension, width. This is getting closer to how humans hear, since we have two ears, left and right. The first stereo recordings were made in Germany in the early 1940s, and it's still the most common format that you will find most recorded music and soundtracks in today. Next came surround sound, which had two spatial dimensions, width to the left and the right, and depth, front and back, with some loudspeakers placed behind the listener. This allowed for further spatial effects where you can make a sound appear to come from all around you, and is popular with cinematic mixes. Surround sound has many configurations with varying numbers of speakers, from 5-speaker 5.1 up to 24 speakers in 22.2, favoured by NHK in Japan. The most recent development in cinematic spatial audio is surround with height. This contains all three dimensions, width, depth, and now height, since some of the speakers are placed on the ceiling. So now you can pan a sound, which is the word we use for moving a sound around the panorama, to the sides, or above, or behind, or below the listener. This means you can make an aeroplane or helicopter sound like it's passing by you overhead. Auro 3D and Dolby Atmos are common 3D surround with height cinema speaker layouts. This is Dolby's test theatre in Soho Square. They have a lot of speakers set up in there, even under your feet. The ground shakes when you are watching a rocket launch on their laser projector screen. All of the above are what we call channel-based audio. Each channel feeds one loudspeaker. Mono equals one loudspeaker. Stereo has two loudspeakers. 5.1, 5 speakers, up to 22.2 has 24 loudspeakers. The kind of spatial audio we will be working with leaves all of these ancient history channel-based audio formats behind. We are going beyond channel-based audio.